Good morning, everyone. Our lesson for today is program development life cycle. So when we want to develop a program using a programming language, we follow a sequence of steps. So these steps are called the phases in program development. The program development life cycle is a set of steps or phases that are used to develop a program in any programming language. In any programming language. Generally, a program development life cycle contains six phases. They are the following, or they are as follows. So the first step is the program definition. Second step is program analysis. Third step is algorithm development, coding and documentation, testing and debugging, and maintenance. For the first step, as you can see in this image, we have here a cycle in which first we are going to define the problem itself. Second, we're going to analyze the problem. Third, we're going to develop an algorithm. And fourth, we're going to code and document. The fifth one is the testing and debugging. And the last one, but initially it will evolve just like a cycle because from maintenance, we're going to go again to the problem definition, so on and so forth. So why this is one is cycling. As we can see, as we go through the sequence of steps, we could be able to understand it. Okay, so let's first discuss problem definition. In this phase, we define the problem statement and we decide the boundaries of the problem. In this phase, we need to understand the problem statement. What is requirement? What is required? What is given? What should be the output of the problem? Or this are defined in this phase of the problem development cycle. So in this phase, we're going to define the problem by analyzing it. Example, we have a math problem. Example, the sum of two numbers. How are you going to, oh yeah, the question is very easy. Okay, get the sum of two numbers. Now, if you're going to get the sum of two numbers, example, in this example, like the problem is to get the sum of two numbers. Now, we're going to understand the problem. This is very easy. We're going to define the problem. We're going to understand the problem. What is the requirement? So firstly, the requirement is two numbers. And what is the output of the problem solution? The output would be the sum itself. And in this stage, we are going to analyze what is the given or what is the requirement and what would be the output. So let's move now with the problem analysis. With the problem analysis, this is the phase 2. We determine the requirements like the variables, functions, and the others to solve the problem. That means we gather the required resources to solve the problem defined in the problem definition phase. We also determine the bounds of the solution. Okay, so here, example, same question, same problem here. Okay. Hmm. We're going to identify the variable. What is a variable? Okay, so let's go and define what is variable. Though the variable itself is already defined in your modules or in your learning materials, but however I'm going to define it, I will not go into the previous lessons because I know that you already read those. So variable, okay, we have here variables. A variable is a quantity that may change within the context of mathematical problem or experiment. Typically, we use single letter to represent a variable. The letter X, Y, and Z are common generic symbols used for variables. Sometimes we choose a letter that reminds us of the quantity it represents, such T for time, V for voltage, or B for bacteria. So here in our example, in our problem, to get the sum of two numbers, so we could have here a variable that will hold the value of the first number, which is num1. So our first variable is num1, and our second variable is num2. So here in this problem, we are going to analyze here what would be the mathematical operation we will be using. So since we are going to look for the sum of the two numbers, the operation we will be using is the addition. So here, we're going to have here we will have here three variables. We will be including sum because the sum itself will catch of the value after the operation. So here, our formula would be sum is equals to num1. The num1 will hold the value of the first number. And we have here num2. This will hold the value of the second number. Now we use the operation plus to get the sum. And the sum variable will catch the result of computation of this part. So we have here three variables. The first variable is num1. The second variable is num2. The third variable we have here is sum. Okay. So we also determine the bounds of the solution in this problem analysis stage. Solve the problem, define the problem definition phase. Again, problem analysis is the phase 2 where we determine the requirements like the variable, the functions, the operation that we will be using, and others to solve the problem. That means that we gather the requirements or we gather the required resources to solve the problem, define the problem in definition phase, we also determine the bounds of the solution. So here we use three variables to hold the first, the second input from the user, or the first and two number na ibibigay ni user. Then we have here the sum the sum variable that will hold the value of the two, that will hold the value of the two variables after the execution of the operation. Let's move now with algorithm definition, algorithm development. Algorithm development during this phase, we develop a step-by-step procedure to solve the problem using specification given in the previous phase. This phase is very important for the program development. That means we write the solution in step-by-step statement. So in algorithm development, we are going to use here an algorithm itself. An algorithm is just like a sequence of steps. Okay, just like how are you going to like a recipe. So how are you going to cook a boiled egg? So first you're going to get a pan, okay, or a caldero that you're going to use. Then you put water on it. Then um, you put water, you boil it, you boil the water, then you put the egg. Then after 2 minutes, I think the egg will be cooked. So that is the sequential step. So in algorithm development, this is also pertains to a step on which how are we going to address the problem. So first, in this problem, in this example, we are going to have a first define, or what are we going to do? Get the the value for num1. Okay. Then after getting the value for num1, anong gagawin natin? This is only an example of creating an algorithm or developing an algorithm. Second, get the value for num2. Then we're going to have here, after getting the value for num1 and num2, we're going to compute for the sum of two numbers using, anong gagamitin natin? Using sum, using this formula. Then number 4, as mentioned earlier in phase 1, in number 4, we're going to display the output. Display the sum of two numbers, or display the result. So ano yung result? What would be the result? Again, it will go back to the sum. Okay? So let's move coding and documentation. For coding and documentation, this phase uses a programming language to write or implement actual programming instructions for the steps defined in the previous phase. In this phase, we construct the actual program. That means we're going to write the program to solve the given problem using programming languages like C, C++, or Java. Okay, so this page or this phase, we're going to code. Okay, next we have here document. Why we need to document? Sometimes documentation, this is like creating some comments or some creating some remarks on the program so that this will be our guide to be able to if we have a lengthy and tedious uh, program, this would be our some sort of guide in solving the problem. Or in, for example, we have a lot of variables. This is our stage or phase that we, for the documentation, we document everything so that we could have a references in the future. So next we have here testing and debugging. Testing, why do we need to test? So during this phase, we check whether the code written in the previous step is solving the specified problem or not. So here we are going to test. That means we test the program whether it is solving the problem for various input data values or not. We must test whether it is providing a desired output or not. So in testing, it's like testing a program. Why do we need to test it? Why do we need to debug? For us to be able to know if it provides us the correct or accurate answer. For debugging, it's for us to know if the program is free from error. What else? In this stage, we are looking for or we're checking for the accuracy of the problem solving. So for instance, we're going to go back to this problem. Okay. So in this problem, okay, we all know that in this problem, we need inputs, two inputs, which is num1 and num2, whatever the input is provided by the user as we run the program, okay, it will provide us, for example, num1 is 2, the value of 2, and num2 is 1, okay. Now, the sum will give us 3, right? Because if you're going to add 2 and 1, it will give us 3. Now, if our operation is minus, definitely the answer would be 1, right? However, there is, in this testing and debugging, we're after to get the sum. However, our operation used here is minus, meaning to say there is no accuracy of result. However, if we're going to change this one as difference, okay, we have a new variable diff, so difference, then it will have a result of 1, since 2 minus 1 gives us 1. But if we're going to change this into multiplication, meaning to say, we are after here to get the product. Okay, now let's go back to the sum. Okay, change again the operation for the two variables. Then 2 plus 1 will give us 3. Meaning to say, in this case, we are having or we are getting and accurate results or accurate value based on the computation we provided during the algorithm or during the coding stage. Okay, here in algorithm, we just create here the sequence of steps, and where in coding, we do here, um, we code the steps, okay? Ilalapat natin yung steps using a language that we will be using in the future, like Java. Then afterwards, we're going to test, we're going to run the program. Then we're going to test if the result of the program is accurate. So for this is an example of documenting or commenting out of the uh, the part of the program. So maintenance. Why do we need to maintain? So this is the last phase. This is maintenance. During this phase, the program is actively used by the user. If enhancement, the word enhancement sounds in this phase, all the phases are to be repeated. That's why we have here a sequence of steps that has that what we call this, that is cycle, because we're now in maintenance. If we if our client or someone who asks us to program that asks for a revision, that's why we do the maintenance. Meaning to say we enhance it. Okay, so let's go back here. So during this phase, the program is actively used by the user if any enhancements found in this phase. All the space are to be repeated to make the enhancement. Why do we need to repeat? In order for us to check every stages if it's correctly done, analyze, and provides us a correct output. That means that this phase or solution program is used by the end user. If the user encounters a problem or wants any enhancement, then we need to repeat all the phases from starting so that the encountered problem is solved or enhancement is added. So just like if we are in the stage of creating or developing a program, so if our client or the user requested that this part of the program shall be changed, or this part of the program, this part of the process part shall be changed, palitan natin yung formula, okay, it is the time that we need to maintain or enhance the program itself so that we could be able to meet the requirement of our client or the requirement of the user. So this one, we already discussed the four stages. Again, the four stages of program development life cycle. So it will start with the problem development or problem definition. Second is problem analysis. Third is algorithm development. Fourth is coding and documentation. Fifth is testing and debugging. Sixth is maintenance. And uh, as we encounter enhancement, it will go through the process again in problem definition, in analyzing the problem, okay, then algorithm development, because we are on the stage of enhancement, coding, testing and debugging, and maintenance. If there is no revisions needed, no need to go to problem definition. Otherwise, pag meron pang anything that needs to be enhanced, babalik siya. Again, the process is cycle. So this is the process of program development life cycle. So if you have any questions, comment out or in a particular line of the video of this video, you may raise your problem so that it will be addressed. I will get back to you the soonest. So hope to see you guys soon and see you around. Thank you. Feel free to ask so that we could be able to address your question. Thank you and have a good day.